I've now downloaded my Arabesque S-Ray data, and you can see that in the data catalogue here on the left in Amazon Athena. If we click on one of these tables, this small triangle, we can expose the fields and the data types within that table. From here, we're looking to package our data to make it useful to our consumers. But before we do that, we're going to want to understand the shape of our data. So here, I've created a query that will aggregate a number of different fields from within that data set. Firstly, I'm going to count the number of records. I'll then count the number of distinct fact set or company identifiers within the data set. I'll do the same for the sector and industry to understand their makeup. And then I'll take an average Scope 1 emission score across all of those organisations and sum those Scope 1 emissions. I'll do that from the emissions data table, and I'll do that where the Scope 1 emissions data is not null. If we query that data and run that query, we can now see that we have over 700,000 records, 2,928 companies, 20 sectors, 128 individual industries represented, and you can see the average and total emissions on the screen. Regularly querying over 700,000 records isn't efficient, so we'll want to package our data views for our consumers. And we'll do that with aggregate functions like the sum, the average and the count that you can see on the screen. But we'll also use advanced functions like the histogram, and that will allow us to maintain the underlying data within the data set when it is aggregated. And as you can see here, we can now see the distribution within individual sectors within this specific data. Thinking about practicalities again for a second, it's likely we actually only really want the most recent data from the data set, as it goes back quite a few years, and we tend to care more about today than this time last year. So to do that, again we can use aggregate functions. So in this example, again I'm going to select the date, the sector, the industry. I'm going to sum my Scope 1, 2 and 3 emissions, and I'm going to conduct a count of the distinct fact set or company identifiers and name that the sample size. Here we'll use histograms to maintain both the country and the region within this output data set, and we'll use a map aggregate that will allow us to map key values of individual companies and their individual Scope 1 emissions so that that data isn't lost. We're going to get that data from the emissions data table, but this time we're going to conduct an inner join. And that inner join can be seen here, and what this will do, we'll select only the max date within that data set and return only the maximum date from the primary emissions data set. You'll now see that that query is successful, and we can see a latest sector industry aggregate view over here on the left. If we wish to see the content of that view, we can select the three dots and click preview. Now let's do the same, except this time instead of emissions data, we're going to want to do the same with the ESG and GC scores data. So here, I'm going to again create or replace a view, this time an ESG GC view, and I'm going to use the same date, sector and industry information, but this time I'm going to conduct averages across these GC total scores and all of the underlying dimensions. Again, I'll seek to understand the sample size, and I'll use histograms and map aggregates to maintain the data that we have at the lowest possible level. We run that query. You'll now see that I have a second view available to me on the left. At the moment, we're using views to query the original data and those 700,000 original records, and that makes our query a little slow and a little inefficient. So to make queries more efficient, we might want to create a persistent table that our users can consume instead. So in this next example, what we will do is, instead of creating a view, we will create a table, and we'll create that table based on our two new views, and from that we will pull through all of the various dimensions of each table where the industry matches on both the ESG and GC table and the emissions table. And if we run that query, you should see a new table appear in the data catalogue on the left, entitled Latest Industry Aggregate. And we're also going to do the same for not just the industry, but also the sector. And because our sectors are made up of multiple industries, again we're going to have to use these aggregate functions like sums to add together all of the Scope 1 emissions, as an example, across all of the industries within a specific sector. We'll also use map aggregate functions to maintain that useful information such as the countries or regions of the individual companies within this data set. As you can see, we're joining our two industry and sector aggregates again, and we're joining where the sector and industry match on both sides of this join. If we run that query, you should be able to see a second table appear on the left hand side in our data catalogue entitled Latest Sector Aggregate. Now that we've got latest sector and industry aggregates, we might actually want to join the fuller data sets for emissions and ESG scores. To do that, we can use a conditional join. So here, again, we're going to create a separate table from the original table so that our users can query that direct. We're going to include many and various fields from the emissions data and the ESG scores data, and we're going to include them where the fact set or company identifier in table A is the same as the identifier in table B. In addition to that, we're going to add another aggregate function, and this time we're going to create 10 percentile buckets that are partitioned by day and will provide us the overall ranking of the individual record within a day for Scope 1 emissions and GC and ESG total scores. If we run that query, that will take a few seconds to run, but once complete we'll have a new table entitled Full GC ESG Emissions Data that we can then begin to visualize in a visualization tool like Amazon QuickSight as an example. So we'll just let this query complete. And that's it, our query's been successful. Now that we have a series of curated tables and views, we can present this data to our end users via a visualization tool. So here in this example, I've provided a visualization of all of the data within the data set. So we can see overall performance indicators with these speedometers. We can see a chronology over time and a forecast of any future ESG scores. And we can see the ESG and GC scores over time alongside the running total of Scope 1 carbon emissions. In the middle, we can see the trends, whether ESG or GC scores are changing over time and the date period that they're changing between. And we can see a heat map of the individual organisations so that we can get a very visual indicator of the strong and poorly performing organisations within this data set. In terms of how you might use this data or this visualization, as an organisation you may wish to look at industries or sectors for due diligence, for maybe preparing tender lists. Alternatively, you may have a portfolio of organisations that you wish to monitor, and you could filter back to those organisations to actively monitor their ESG, carbon emissions and GC scores over a longer time period. Imagining that we've already applied a filter to this data set, maybe for organisations within our portfolio or organisations that are part of a tender list. What we can then do is look at these organisations in a visual manner using the ESG and GC scatter plot. The scatter plot provides us with a very visual indicator of the organisations who are performing well in both ESG scores and GC scores. The size of the individual data point represents the Scope 1 emissions, and if we move our mouse onto the data sheet, we're now able to drill down into those high or low performing organisations to understand not just their ESG and GC total scores, but also industry and sector, and the metrics and dimensions that underpin those top level scores.